Hello, welcome to this video. In this video, we will get started with Python for data analysis. So if you are working with Excel, for example, and you always wondered, how can I use something like Python to analyze my data? Well, then this is exactly what we will dive into now. Because we will have a look at how we can set up Python correctly to make sure we can use it for data analysis. We'll then have a look at how we can access a CSV file, a typical Excel use case, for example. So how we can access the CSV file and how we can access specific columns or rows in that file. And finally, how we can also plot a quick chart using Python. That's it actually. That's just the basics, of course, but you have to get started somehow. So let's get started together in this video. To get started, we have to install Python first. And we basically have two options to do so. One option would be to directly download Python. The alternative would be to use a Python distribution. Now, what's the difference and what do I recommend? Well, the direct download would mean that you go to python.org, download the Python language basically there, and follow the installation guidelines. Pretty straightforward, actually. There is also no problem about doing it like that. The only problem, especially for beginners, is that Python is an open source language, and Python is a really powerful language. This means you can use it for data analysis, for machine learning, but also for things like web development or even for creating desktop applications. This means that using the plain vanilla Python, so just the pure code we have, can work, but it would be nicer to have some tailored, specific functionalities which better meet your requirements. Because if you want to build a web page or if you want to analyze data, well, as you can imagine, there are different things that you would like to do with that language. And for that, Python comes with a lot of different packages and libraries, which add such additional functionalities and such convenience functionalities to that language. The problem is that the direct download Python version doesn't come with these packages. It does come with pip, Python's integrated package manager though, and with that pip install command, just in case you saw it somewhere already, you can install the different packages you need. So this is working, nothing wrong about that, but using a Python distribution is a lot more convenient, especially because of these packages. Because you could go to anaconda.com, for example, download the Python distribution from there. We'll have a look at that in a few seconds. And with that, you install Python and a lot of the most common packages that are used together with Python. And because of that increased convenience, I definitely recommend using the Python distribution if you just get started with Python. Now let's go to anaconda.com together and see how this basically works. Because it works pretty straightforward, to be honest. You just go to anaconda.com and now you can scroll down a bit. Here you can see some Anaconda products, and the product of your interest should be the Anaconda distribution right here. As you can see, it's the most popular Python data science distribution, so I think that's not the worst choice in our case. Just hit download now right here and select your operating system. In my case, this is the Mac. And down here, you can now download the installer. Choose Python 3 right here, by the way. That's what I would recommend. And then you can decide if you want to use the graphical installer or the command line installer. I would use the graphical installer. It's a nicer interface. And then you can simply follow the installation instructions. And with that, you are already done. So you are basically ready to use Python now after installing this Python distribution. Sounds quite awesome, sounds quite easy, it definitely is. But before we dive into the Python code, we have to think about one more thing. What is the working environment we want to use in Python? Because writing Python code can be done in a lot of different ways. One way would be the REPL. REPL stands for read, eval, evaluate, print and loop, and basically means that we can write Python code in our command prompt or in the terminal on the Mac. This is not a big issue in general. You can do that and it's quite nice to get started. You only have to type Python 3 in your terminal and then you can basically get started. There is no additional installation of an IDE or of some code editor needed, but it's rather a code playground. So, as I said, nice to get started, nice to play around, but not what we will use in here. The second alternative would be to use an IDE or a code editor, PyCharm or VS Code, for example. These code editors are nice because they come with some additional convenience features like version control or debugging. And especially if you're coming from a web development world, you're quite used to such code editors. So nothing wrong about these, by the way. You can use code editors. But as we don't want to create a web page, but as we want to analyze data, there is a third, and in my case, also preferable option, especially if you want to get started with data analysis, and that is using a Jupyter notebook as our code writing environment. A Jupyter notebook, in simple terms, well, simply means running Python code in the browser with a tailored or Python-specific interface. The cool thing is that it runs in the browser, but it runs locally on our machine. And if this sounds strange to you, no worries, we'll have a look at that in a few seconds. But more information about it can be found on jupyter.org. And as I said, the cool thing is that it's an interactive browser interface for the Python code. We can see our input and our output at the same time. So if I enter code, I can see the result of this code also in this browser window. This, by the way, also includes visuals, as we will see throughout this video. And therefore, it's, in my opinion, the best environment to get started with Python. Now the question is, how can we install such a Jupyter notebook? Well, you can go to jupyter.org and download it, or you can simply open the terminal or the command prompt and now type conda list. What does this mean? Well, we installed Anaconda. And just as Python comes with this pip, this integrated package manager, Anaconda also comes with an integrated package manager. This is simply called conda right here. And with this conda list command, and with hitting enter, you can find a list of all the packages we installed as part of our Anaconda distribution. So these packages are now installed on your system. And if we scroll up a bit to the J, right here, we can see that we installed Jupyter already. So this is exactly this Jupyter notebook I was referring to. And what does this mean for us then? Well, this simply means that we can now immediately start writing our first Python code in such a Jupyter notebook. For that, I will create or open a new tab, like this up here with new tab. And now just enter Jupyter notebook, like this. If we now hit enter, the Jupyter notebook gets up and running. And now you should see your Jupyter notebook, so this browser window, running with that, well, specific tailored interface in the end. I navigated into a project folder already, so please do the same because, well, you can create that notebook then in the folder of your choice. And if we now go right here to new, to the right part of that page, we can either create a new notebook, which is what we will do in a few seconds, or you can also create a text file or a folder, for example. We don't need that. We just want to create a Python-free notebook because that's the Python version we installed. So if we click onto that, we see this new window with a so-called cell in here. The cell is the part in the Jupyter notebook where we can write our Python code. And we can also rename that up here if we click onto Untitled and maybe call it Python for Data Analysis, something like that. No need to do that though. So this is how you can rename such a Jupyter notebook. And in here, we can now write our Python code. For example, to start really complicated, let's say 2 + 2, like that. And now you can either hit run right here, or let's do maybe 2 + 4 maybe, or hit Shift and Enter. This will basically run the code and, really important, show the output right here immediately. That's also what I referred to when we had a look at the slide. The notebook allows us to see both input and output immediately and on the same page. And this is quite cool actually. However, there are two more things that we have to change or understand before we can finally dive into our data analysis code. The first thing is we need an input file, a source file that we want to, well, get access to. For that, you can find a link to the source file below the video in the video description. So simply click onto that link and download the file. And then simply take that file, it's called Revenue Profit CSV, and drag and drop it into the folder where you created that Jupyter notebook. In my case, this is this basics folder, and in this folder, you can see this Python for data analysis IPYNB file. That's the file type Jupyter Notebook basically creates and uses. And into this folder, just drag this revenue profit CSV file. So this was one thing, this was adding the source file, but there is also one second thing we have to understand before we can finally start analyzing our CSV file. And this brings us to the last slide in this video. Because we talked about it, Python is an open source language made for basically any kind of purpose, and therefore we can install additional packages. I talked about that already. Python is also coming with some built-in modules though. You can find out more about these if you Google for the Python standard library. But especially for data science purposes or for data analysis purposes, you would install optional or third-party packages and libraries. Now, there are lots and lots of libraries and packages available, but 3 of the most common ones you will, probably use is NumPy, Pandas, and Matplotlib. Now, what are these packages doing? Well, NumPy simply adds multidimensional array support, so basically being able to read columns and rows in Python, in simple words. Pandas allows us to add improved or better data manipulation and analysis features to Python, and Matplotlib basically allows us to visualize information. Now, if you think about what we want to do, we want to read data, analyze the data, and visualize the data. These packages don't sound too bad. Now, the great thing about these packages is that we got them installed on our system already. Because remember what I said about Anaconda, that Anaconda comes with, actually all of the most popular packages by default. So if we go back to our terminal right here, so not into that part, but into that part where we had that conda list command. And as we saw Jupyter right here, we can also see that we have, for example, Matplotlib right here, or Pandas right there, or NumPy right there. Not right there, this one is NumPy. So this means we got these packages installed in our system, or on our system. We only need to import these now to our project. To do that, I'm back in my Jupyter Notebook, and now we can simply type import NumPy as NP. That's the typical way how we import NumPy to our projects. And we can also import Pandas as PD, also the typical way how we import the Pandas package. Hitting Shift and Enter will basically, finish this import. This means we can now use this data. And specifically, we will use the Pandas package right here to access our CSV data. So let's maybe call this functionality, this reading functionality, content, maybe like that. And content should be equal to PD dot. This basically means that we now want to access a function that is available in Pandas. And if we now hit Tab, you can find a lot of different functionalities that are implemented into this Pandas package. Now, if we scroll down a bit, right here, we can see this pd.readCSV functionality. As we want to access a CSV file, this doesn't sound like the worst plan. So if we click onto that, we can basically access the CSV file now. We only need to tell Python or Pandas the file name or the path of our file. For that, let's add brackets right here, and let's now insert another cell below our current one, like this. Because in our case, the Jupyter Notebook file and the source file are in the same folder, in the basics folder. So if we now type ls, like that, you can see that we have our Python file and we have our revenue profit CSV file. And that's exactly the name that we can select now. So select it and copy it. And now paste it right here into the brackets. Make sure to also add single quotation marks, otherwise this doesn't work here. And you can also select the cell right here with the ls, we don't need it anymore. Hit escape and press D 2 times, like that. This deletes a cell. A nice feature that might be helpful in some cases. So with that, we now said that if we use content right here, we want to read the content of this CSV file. So let's press Shift and Enter. And as you can see, nothing is displayed here as an output as we saw it before. But if we now type content like this and press Shift and Enter again, then we can see the output of our, or basically not the output, the content of our CSV file. We can see that we have some problems still though, because apparently the delimiter is not correct in our case. Now the great thing is that besides adding the file name or the path, including the file name if the file is not located in the same folder as it is the case for us, you can also add other parameters here. So if we enter, or if we add a comma, and now say sep, like this, equals, now single quotation marks, now we can define our separator, our delimiter right here. In our case, this should be a semicolon. So if we add the semicolon, and now important, run this cell right here once again. That's important. You always have to rerun the cells to make sure the changes are applied. And now run this cell once again. You can see that our file is displayed correctly now. Now, talking about files and being displayed correctly, what do we actually see right here? Well, if we click into this cell and now enter type and now enter content, so the type of the content that we displayed right here, and again press Shift and Enter, then we can see that Pandas created a so-called data frame. Now, I don't want to dive too much into the details of these data frames, but the important thing is that a data frame simply represents this structure right here. So we have a tabular structure, and that's important, an indexed tabular structure. This means we have an index for our rows, 0 to 7 in our case, and we also have an index for our columns. This index is automatically created in our case because the CSV file had headers, so our headers basically are now the index for our different columns, but you could also create these indexes on your own. Nothing we'll have a look at in this video though. So let's just keep in mind that we have a data frame here, which is a structure that is created by Pandas, and that we can use this data frame to basically access our columns and rows by certain indexes. We'll see how this works in a few seconds. Now with this data frame structure, we also get a lot of data frame functionalities, you could say. Now what do I mean by that? If I enter content here once again, and now type head, and add brackets and press Shift and Enter, you can basically see the same structure we had before. The difference now is that we don't have a preview of our entire content right here, but that we only see a preview that we can define on our own. Now what do I mean by that? By default, the head gives us back the first 5 rows of our file. But if I enter a 3 into these brackets right here and press Shift and Enter once again, you can see that we only see the first 3 rows. Guess you see how this works now. If I enter 4, we get 4 rows and so on. And if we enter 8 right here, because we have 8 rows, 0 with the index 0 to the index 7, well, then we get the entire content. So that's already a specific data frame functionality of Pandas. But we have more of these. For example, we can see that no data right here apparently is not the right label for our column. We can easily rename that in Pandas. For that, I'll again set content equal to something. And this something simply is content dot. Now hit tab again. And now you can see that we have a lot of different things that we can do with our content. One interesting thing down here, if we scroll down, is that we can rename it like that. Now we simply open the brackets once again. And what do we want to rename? Well, we want to rename a certain column. For that, we simply type columns like that, equals, and now curly braces. And now we need 2 things. We first need the name of the current name of the label. So this is no data in our case. Now we add a colon, and now we define the new label name that we want to have, which is year in our case. I guess this makes sense. If we now press Shift and Enter, we can see nothing. But if we now again say content, head like that, maybe 4, 5, you can see that year now replaced no data. So we can also easily access the data and change it right here in our notebook. Now with that, let's say our data looks fine, and now we want to access specific rows or columns. Let's start with a specific row maybe. So let's say we want to have the single year, let's say a specific year, and we want to retrieve the data only for the year 2012, for example. For that, we could say content, because that's what we want to access, And specifically, we want to access the year column of our content, so of the table right here in our CSV file. We can then set year equal to 2012, like that, and now press Shift and Enter. And if we now simply say single year, like that, then you can see that we retrieve the data for the year 2012 only. So this is one way how we can access specific rows. Now, what about columns then? Well, we could also say that we want to access a single column. One way to do so would be to simply type content right here, and after content we now can specify which column we want to access. In our case, this could be the revenue. If we now press Shift and Enter and type single column right here, then you can see that we only got the data for the revenue column, so 100, 100, and so on. If you want to access multiple columns, by the way, you could also write something like this. So you open the curly braces 2 times and now say you want to have revenue like this and profit like that. If you do that, you can see that we have the revenue and the profit columns both in our table right here. Now, these ways to access data are fine, but I don't think these are really clear and really, well, flexible, as I would call them. Because of that, we have another functionality implemented into Pandas, which makes things like that a lot easier. The so-called log argument. Now, what does this mean? Well, we can simply access our content, so up here, the content right here, once again, by typing content, and now we add log to it, like that. And this simply allows us to select the rows and the columns by their label names. And this makes this really easy to use, because we can see right here that for the rows, we have the label names from 0 to 4, actually not 4. If we increase the head, we could see that it's 0 to 7 actually, and that we have column labels named year, revenue, cost, and profit, and so on. Now, what does this mean? Well, let me maybe first add another cell above right here, and let's print out the head one more time to see our entire table right here. Now, what I could say here is that I would like to have the row with the label name 2, and I want to have the column with the label name revenue, something like that. If I do this, you can see that we get 130. That's exactly what we can see right here, because the revenue in the year 2012 was at 130. But we can do more. Let's say we also want to add the year 2015. For that, we can simply add 5 right here, but now put both of these into curly braces. Otherwise, this wouldn't work, like this and like that. So what we basically want to have is, we want to display the revenue column, or the revenue basically, for the years with the label 2 and 5, so 2012 and 2015. If we now press Shift and Enter, well, you can see that we get 130 right here and 179 right there. The same logic, of course, also applies for the column labels. So if we add square brackets right here, and then simply put the revenue right here, and now also add the profit, for example, like that, and press Shift and Enter, you can see that we get the 2nd and 5th label name for the row and 2 columns for revenue and profit. You could also say that you want to have the data for a specific range of years. So let's say you want to start in the year 2012 and you want to have the data up to the year 2017. For that, you could say you want to have 2 up to 7 from the label name perspective. To do this, you can get rid of the square brackets here and simply type 2 to 7. Like that. Important, this refers to the label name, so this includes all of these rows. So if I enter Shift and Enter now, then you can see that we get all the data from the year 2012 up to the year 2017 for our column right there. And of course, we could also include the year, for example, right there, to make sure we can actually see which year we are referring to. If you would like to have all columns to be included right here, then you can simply also do it like this, delete that, and add the colon right there. If you do that, you can see that we added all the columns and the selected rows as we defined it right here. You could also do it like this, this would also work, but it's not the best practice code from a Python perspective, because we should always be as precise, as clear as possible about what we want to achieve with our code. So definitely make sure to add the colon right here. Same result, but better code in the end. So this is how we can basically tailor the columns and the rows that we want to display right here. I also want to show you another functionality. This is not the log argument, which, just to keep that in mind, refers to the label names. So this one right here and the label names right here, our index that we have for the different rows. But we also have ilog, like this. Ilog simply refers to the integers, you could say, of these different rows and columns. Now, what do I mean by that? Well, let's simply add ilog and let's simply press Shift and Enter. And as you can see, the way our table is displayed changed a bit. For the columns, it remained the same because we want to display all of our columns. But for the rows, we still have the year 2012 included right here. But we don't have the number 7, you could say, so the year 2017 included here anymore. Now, the reason for that is that log referred to the label name. And we wanted to have the label name included here. So it was there, so we have to put it also into our output. Now for ilog, the behavior is different. Ilog excludes the last value right here. So we basically include the label number 2, but we exclude the last one. That's an important thing that you have to keep in mind. This is simply how the two different arguments behave. What you can also do here is you can add something like revenue, for example, and then access the revenue. That's not working. Why is it not working? Because as I said, ilog refers to the integers. So you have to write numbers here, the index numbers, to be able to access the different data. Now, what does this mean for the revenue? Well, the revenue right here has the index 1. Why does it have the index 1? Because the index starts at 0 in the first column, so with year, and then it continues with 1 in the second, third is then 2, fourth is 3, and so on. So if I enter right here 1 now and press Shift Enter, you can see that we have the revenue column right there, and, well, we know it from before, the specific rows as defined by our index numbers. We can also add a colon and maybe 3. So this would be 0, 1, 2, 3. But if we hit Shift and Enter, well, you can see that the profit column is not included, again because of this behavior that ilog does not include the last index number right here in the result. As I said, just something that you have to keep in mind. So let's maybe add the year once again. I think it's the better way to display this data. So let's say that this is our final table now, which includes all the data that we want to display. So for that, let's now set content equal to this content that we have right here. So if we now press Shift and Enter and now say content head once again and enter 8, you can see that we don't display 8 rows as in the beginning, but only the 5 rows and the 3 columns that we now defined for our content right here. With that, we can now continue with 2 last steps that I would like to show you in this video. One thing is the describe argument, because it allows you to get a really big or quick idea of some statistics related to your data. So simply type content.describe right here and the brackets. And if you now hit Shift and Enter, you can see some really basic statistics about your data. You can see that we have 5 different years, so 5 different revenue data and cost data. You can see the mean, you can see the standard deviation, and you can see a minimum and a maximum value, for example. So I won't dive too deep into that. I think it's quite straightforward. I just wanted to make sure that you are aware of this functionality, also included in Pandas, by the way. So this is one thing, the describe argument right here. Now let me conclude this video with plotting a quick chart. I said that we will need the Matplotlib library and that we installed it already as part of the Anaconda Navigator. So before we create that quick chart, let's go to the Matplotlib page and see what Matplotlib actually is. So here we are on matplotlib.org, and well, as you can read right here, Matplotlib basically allows us to quickly create nice and tailored, so individually tailored charts for our Python code and for our data, therefore. Now, I won't dive into this entire documentation in this video, A nice thing to see though is this examples page right here, because if you go to the stack bar graph, for example, you can see a chart type and what it could look like in Python. And you can also see that we have some example code down there. So feel free to play around with this code and create your own charts. And as you can see also by this import, we will use Matplotlib, well, specifically in connection with pyplot, which you can find right here, which basically provides a MATLAB-like plotting framework for our Python code. We won't dive deeper into this right now. The important thing is that we can simply take this command right here and create our chart right there, a quick line chart, by the way. So back in our Jupyter notebook right here, we can now import Matplotlib .pyplot, as we just saw it, as PLT. And important, to be able to plot the chart here in line in our Jupyter notebook, we have to enter %matplotlib, like that, in line, like this. So if we now press Shift and Enter, we should be ready to go to put these data into our chart. Let me maybe print the head once again, to make sure we can see which data that we actually want to print here. Now, how can we do this now? Well, we can refer to our, pyplot right here as PLT. So let's type PLT dot plot, that's the first thing. And now we have to specify what data that we want to display in this chart. Well, in our case, I would say that the x-axis could be the year, so content.year. And for our y-axis, I would say that we basically just want to display our revenue. So let's say content.revenue, like that. So that's the data that we want to display right here. What we then need are some labels. So let's type PLT X label once, and let's give it a name of, year. And then we need a Y label also, which should have a name of, revenue. And now we finally want to make sure that we can display this chart. So let's simply type plt.show like this and hit Shift and Enter. And with that, we can see that we now created our first chart. We can see the name for the y-axis, for the x-axis. We can see that we have some issues with our dates though, but that is something we won't dive too deep into now in this video. And we can also see that we have our revenues displayed right here. Now that's for sure not the most beautiful chart in the end, but still we made it from Python installation up to connecting or reading data from a CSV file. We even renamed column labels, we selected or accessed specific columns and rows, and we finally created a, not too beautiful chart in here. So this is it with this getting started video. As you can imagine, we are just at the very, very basics of Python and its data analysis capabilities. But still, these are the first steps that should help you to get a grip onto Python in relation to data analysis. So I hope that you liked this video and that this was helpful for you. And of course, I hope to see you in one of the next videos, maybe also related to Python and data analysis. So thanks a lot for watching and see you in one of these next videos. Bye.